Super Crank-A-Vator IIs, Crank-A-Vator IIs, and Lowboy Crank-A-Vator IIs are products that may need periodic adjustments and regular scheduled maintenance. The Vator you're looking at is owned by a major motion picture studio and has not been serviced from the time it was originally delivered 4.5 years ago. Just like an automobile or any other mechanical device, it needs maintenance and upgrades in order to keep it working properly. In this short video, we will be guiding you through the various steps in properly maintaining all crank-a-vators within the Vator family. I will now be going into detail as to how you maintain your Vator, and will be showing you the detailed prints of each mechanical part within the Vator. The Vator II family requires a yearly tune-up on the nuts, bolts, and transmission adjustment. The following is a top-down list on the torque adjustment to retighten the stand. As with all Matthews products, the Vator family is constantly being upgraded. Contact Matthews for current upgrades on your stand. Starting with the top light receiver, remove the 3/8 T handle with round tip and replace it with the 3/8 T handle with the serrated tip, and if needed, chase threaded holes. This is considered an upgrade. Check the 3 set screws on the light receiver, and if they are loose, remove them and add Loctite 2440 to the set screws and hand tighten. For the gear rack collar, check the set screws, and if loose, remove them and add Loctite 2440 to the set screws and hand tighten again. For the main body casting, remove the 3 button head screws that attach the main housing to the base tube. Remove each head screw one at a time, add Loctite 2440 blue and torque to 10 foot-pounds. Remove the 3 head cap screws one at a time, add Loctite 2440 blue, replace and torque to 10 foot-pounds. For the rolling block right, left, and center, do not remove them, but simply torque to 10 foot-pounds. For the rolling block to leg bolts, do not remove them, but simply torque them to 10 foot-pounds. For the wheel support, remove each screw one at a time, add Loctite 2440 blue, and torque to 20 foot-pounds. For the lower spider rolling block bolts, remove them one at a time, add Loctite 2440 blue, and torque to 20 foot-pounds. For the lower clevis block, right, left, and center, do not remove, but simply torque to 10 foot-pounds. For the stop collar, remove the Allen screws one at a time, add Loctite 2440 blue, and hand tighten. If the end cap bolts are loose, remove them one at a time, add Loctite 2440 blue, and hand tighten. For the wheel support yoke spindle, remove the wheel and fork, holding the collar on the spindle below the wheel support. Torque to 55 foot-pounds on the upper nylock nut. Clean and replace wheel fork and torque to 55 foot-pounds on the lower nylock nut. These must be done separately, as if they are both torqued at the same time, it will not work properly. These black rubber spacers were originally installed to help prevent the operator from pinching his or her fingers when folding the stand, and has been realized that these spacers may bend the legs when compacted too tightly for storage. Replacing these with the new larger spacers and relocating them to the lower part of the leg will eliminate any chance of bending the leg and will still provide proper clearance in protecting the operator's fingers. The following tools are required when adjusting the transmission: a strong but small magnet, a 9/16 crescent wrench, a 3/16 Allen wrench, a 5/32 Allen wrench, and a couple of small pin tools. When adjusting the transmission back pressure, it is recommended you adjust to the weight of your heaviest fixture. You may use your fixture atop the stand for this purpose. When adjusting the transmission, loosen the nut and then adjust accordingly using the Allen wrench and crescent wrench. When making your adjustments, be sure to test the transmission by cranking your weight or fixture up and down. Make sure you have enough back pressure applied when doing so, otherwise the stand will freewheel, crashing to its lowest position. Please be cautious. When replacing the transmission and/or its component parts, all risers must be completely down and free of pressure. Loosen the nut all the way out using both the crescent wrench and Allen wrench. Once that is done, use the 5/32 Allen wrench and remove the 3 set screws from the transmission housing. When removing the cap, use the pin tools to loosen it and gently remove it from the housing. Make sure to be aware of the washers too. They should slide out with the cap, but be sure to keep them in their original order. When removing the interior parts, the serrated discs, brake pads, and bearings, it is best to use a strong magnet to pull them out carefully. The pieces of the transmission come out in the following order: the serrated disc, the brake pad, the one-way bearing, another brake pad, and the last serrated disc. Once the transmission has been disassembled, clean, inspect, and reassemble it in the following order. Replace your first serrated disc with the serration facing outward. Replace the brake pad with the serration also facing outward. Once this is done, insert your one-way bearing with the side containing the small lettering facing outward. Be especially careful when replacing the one-way bearing to not invert the bearing, otherwise the transmission will become inoperable. Replace the other brake pad with the serration side facing in toward the bearing. Once this is complete, replace the last serrated disc with the serration facing in toward the brake pad. If you find that your washer configuration is out of order, make sure the first 2 sets of cone washers face each other and the last one faces outward. Once that is complete, replace your washer configuration by inserting it into the cap and reposition the cap gently into the transmission housing. Once the cap is replaced, insert the adjustment screw into the first 3 or 4 threads. Finally, insert the 3 set screws and tighten each to approximately 10 foot-pounds. You are now ready to begin the back pressure adjustment procedure. If maintained properly and on a regular basis, the family of Super Vator IIs will provide many years of satisfactory performance.